Right, we're going to have a look at the answers to your volume of cylinder questions. So lesson 2 on your 3D shapes section. So start with question 1. So we've got the area of the cross section, so the circle at the top, pi times 4 squared and then times the length of 10. And if we pop that into our calculator, gives us 502.7 centimeters cubed to 1 decimal place. Question 2. This time we've got a radius of 8 centimeters. So we're going to have pi times 8 squared times the length of 30. And again, pop that into your calculators to get 6,031.9 centimeters cubed to 1 decimal place. Question 3, this time we were given the diameter, not the radius. So we had to halve the diameter before putting it into our formula. So we've got pi times 5 squared times the length of our cylinder 9. And again, popping that into our calculators and rounding to 1 decimal place, we should get 706.9 centimeters cubed. Right, question 4. Again, we've got a diameter and not the radius, so we need to halve that before we put that into our equation. So we've got pi times 2.5 squared times the length of our cylinder 17. So pi times 2.5 squared times 17 to 1 decimal place gives us 333.8 centimeters cubed. Question 5. So this time we're trying to find the height given the volume is 800. So we're going to substitute what we know into the formula. So we've got pi times the radius, which will be half the diameter, so 4.5 squared, times the height, which we are told is all equal to 800. So we're going to rearrange our equation. We're going to divide both sides by pi times 4.5 squared. Which leaves us on the left-hand side of the equals with just h, and on the right-hand side with 800, all divided by pi times 2.5 squared. So if you type that into your calculator, so 800 over pi times 2.5 squared, you'll get an answer of 40.7 centimeters to 1 decimal place. So that's the height of your cylinder. Question 6, finding the height again. So this time we've got a radius of 0.2 meters and we're told the volume equals 0.11 meters cubed. So we'll substitute in what we know again. So pi times the radius squared times the length or the height, which is all equal to 0.11 meters cubed. Going to get the h all on its own. Divide both sides by pi times 0.2 squared. So we're left with h equals 0.11 divided by pi times 0.2 squared. And if we type that into calculators, So 0.11 all divided by pi times 0.2 squared gives us a height of 0.9 meters to 1 decimal place. Question 7, this time we're trying to find the radius. So again, we're going to substitute in all of the information we know into our volume of a cylinder formula. So we've got pi times the radius squared, which is expressed in terms of x in this question, times by the length of 12, and that's all equal to 9,000 centimeters squared. We need to isolate the x squared and get that all on its own on the left-hand side of the equals. So we are going to divide both sides by pi times 12. So we're left with x squared equals 9,000, all divided by pi times 12. We still haven't got the x all on its own because we've got x squared at the moment. So we need to square root both sides to get rid of the square. So we're going to have x equals the square root of 9,000 all divided by pi times 12. So x equals, we pop that all into our calculators, so 9,000 over pi times 12 to 1 decimal place. That will give you 15.5 centimeters. Question 8. So same again, this time it wants us to find the diameter. So we're going to substitute what we know we've got again. So we're going to have pi times, this time I'm going to call it r squared still, just because this time the radius isn't called x, the whole diameter is called x. So I don't want there to be any confusion at the end. So I'm going to keep it as r squared for the moment, and I'll explain why again at the end. Times by the length of 9, and that's all equal to 170 centimeters squared. We're going to isolate the r squared again by dividing both sides by pi times 9. So we're left with r squared equals 170 all divided by pi times 9. And then we're going to square root both sides. So we're left with r equals the square root of 170 all divided by pi times 9. So we pop that into our calculators. 170 divided by pi times 9. We're left with a radius of 2.5 centimeters to 1 decimal place, but the x that we're trying to find is the whole diameter. So we need to times that 2.5 by 2 to get the full diameter, so our answer is 5 centimeters. Now, challenge 1. We've got half a cylinder in this problem, so we're going to work out the volume of a full cylinder, and then we're just going to halve it at the end. So we're going to start with pi times the radius, which is 3.5 squared, times the length of 12. We're going to type all that in. So pi times 3.5 squared times 12 leaves us with 461.8 centimeters cubed. However, we've only got half a cylinder, so we're going to halve the volume of our whole cylinder. So 461.8 divided by 2 . 461.8 divided by 2 leaves us with 230.9 centimeters cubed. So that is your final answer. And lastly, challenge 2. So we were given a crate with some cylinders inside of it. We were told that the radius of each cylinder was 4 centimeters. The height of the box was 14 centimeters. So we know that each cylinder is 14 centimeters tall and the box was the same. Now we needed to work out the percentage of space inside of the box that was empty. So all of the spaces in between the cylinders. So we need to work out the volume of the whole crate, the whole box. We need to work out the volume of all 6 cylinders and then express the volume of the cylinders as a percentage of the volume of the box. So we're going to start by working out the volume of the box. Now we need to work out the whole length and the whole width. Now all we were given is that the radius equals 4, and we were told that all of the circles touch. So that's going to be another 4, another 4, another 4, another 4, and another 4. So we've got 1, 2, 3, 4, 5, 6 lots of 4 across. So 4, 8, 12, 16, 20, 24. So we've got a length of 24 centimeters. And our radius works exactly the same going the other way. So we've got 1, 2, 3, 4 lots of 4 going down. So we've got a width of 16 centimeters. So then we can use the height of 14 as well. So the volume of our box, so volume of box equals 24 times 16 times 14, which gives us a volume of 5,376 centimeters cubed. So now we need to work out the volume of our cylinders. So we'll start with the volume of one cylinder. So we're going to find the area of the top of one of our cylinders first. So pi times 4 squared, and then we're going to times that by how long our cylinder was. So we were told the height of our cylinders are 14. So pi times 4 squared times 14 gives us 703.7 centimeters cubed to 1 decimal place. But of course we've got 6 cylinders altogether. So we're going to do 703.7 times 6, which gives us 4,222.2 centimeters cubed. So that is the volume of 6 cylinders. Now we need to express the volume of the cylinders as a percentage of the total volume of the box. So we're going to do that by doing 4,222.2, so the volume of our 6 cylinders, divided by the volume of our box, so 5,376, and we're going to multiply that by 100 to turn it into a percentage. So if we pop that into our calculators, 5,376 times 100 is 78.5%. So that's the percentage of the crate that the cylinders take up, and we were asked to find the percentage of the crate that's empty, so not space taken up by the cylinders. So we need to take that 78.5% away from 100%. minus 78.5%, which leaves us with a percentage of 24.5%. So that is the percentage of empty space inside of our crate.